Hey guys, so I just bought this Elegoo Elegoo kit, and I wanted to learn some cool new electronic stuff. I've never done anything like this before. I am a software engineer, so I have that, but hardware is kind of seemed interesting to me these days, since everything is just turning into AI anyways. So yeah, I just wanted to go over this kit and see what I can create. So here's the box. You can see all the parts listed on the inside here. All the stuff, I have no idea really what it does yet. I do know that I'm gonna need this breadboard. Let's get this bit out. Get this set up. The other thing that I got was this silicone soldering mat, soldering mat, which I don't really know that I'm gonna need yet. I haven't bought a soldering iron or anything, but it comes with this anti-static wristband, which is kind of overkill right now, but I just wanted a nice surface to build some stuff on. So yeah, gonna dig into some of this stuff. I really don't know anything about this, but it's so pretty. Look at it. So I think for my first project, I'm probably just going to do the most basic thing, which is try to make an LED blink. So let's see if we can just find the LEDs in here. And let's go with green, because why not? I wanted to go over some vocabulary too that I learned. So this breadboard. Resistor is what reduces the power so that you don't overload things on your circuit. For example, this LED, just plugging it in would overload the LED. Circuit controller board and jumper cables. It seems like these all work just the same, but this pack came with a nice bundle of them that you can use. Here's my red and black cables that just can tell you the positive or negative. So the first thing we have to do is download the Arduino IDE. You can do that from their website. I picked the Mac Silicon version because that's the one that I need. I also found they have this good Blink tutorial, which I used for this. It allowed me to see basically the general instructions on how to achieve this for the Arduino board. You can see that there's the first sketch here that just comes out of the box. I set this pin mode to the built-in LED. Down here later in the documentation, it describes methods you can use. But let's go down here. It shows this loop that we're going to need. I'm just going to copy this, bring it over to the IDE, and use that in my loop function. Now this will turn on the LED, wait for a second, and then turn it off. I'm going to save it as Blink Sketch and select my board. But before I upload it, I'm going to hit verify, which is going to make sure it can compile. And then I'll hit to upload it to the Arduino. Okay, so look at this now. It's blinking. I have 200 milliseconds. And okay, so now let's make it for 5,000 milliseconds. So it should probably be about 5 seconds. And then I'm gonna hit upload again and watch this little, see that RX and TX blinked now. Four, 5, 1, 2, 3, 4, 5. Okay, now I want to try with this green little LED. Where's the camera? There. Focus. There we go. Got this little green LED I want to use instead. Here's the diagram for the blinky light. And it says H3. There's the resistor to H6. So the instructions for blink say take the long leg of the LED, the positive leg is called the anode, and connect it to the other end of the resistor. Connect the short leg of the LED, the negative leg called the cathode, to the GND. So 6 and 8, 7, 8. Okay, so I had it right. It's GND is the ground, so that's going to be the negative. So I don't know if it matters to do this while the Arduino is off, so I'm just going to disconnect it and plug it in and then plug it back in. Write my sketch first and then see what happens. Look at this here. This is G8 where I gotta put the ground wire. So G 1, 2, 3, 4, 6, 7, 8, and that's the same as where the LED is. And I'm gonna plug it into the board, which has these nice little labels right here on the side for the black ground. And I'm gonna use 13 because that's what the guide instructions say. And now let's see if we need to change our sketch. So what I'm learning is, because the positive that's coming out of this board can power more than just what a simple LED needs. That's what the resistor's for. It's preventing the LED from getting overloaded. So looking here, it's preventing that LED from getting overloaded. So my sketch is ready. Let's see what happens. So coming back to this sketch, LED pin is 13, which is the pin number we used on the board. We set up the pin mode, and it should be for 1 second, and then let's try to upload it. Oh, LEDs declared. The scope compilation LED pin does not have a type. So it seems like this is a typed language, probably, I guess, like C++ adjacent. Okay, let's try it again. This is an integer, so let's try it uploaded. Now what's gonna happen? Nothing. Still blinking the onboard LED. Okay, I'm learning some things about this breadboard. So these lines here, so the third, which is what we so carefully put the positive into, is one metal channel underneath here. So that's how, when the power supply comes in from this red line, it can transfer over this resistor and gets the power gets restricted so that it doesn't overload this LED, and then it transfers into this LED, and then it should, since this shares the channel with the negative line, that's what should take it from the negative line and create the full circuit. I'm having some trouble with my board. I changed the LED pin to 8 because I learned that 13 is the onboard LED, and I was still seeing just the onboard LED blinking and not my new circuit. So I changed it to LED, and look what happens. Blinks, and everything kind of stops. So, not sure exactly what the problem is here. Okay, I've been scratching my head on why I can't get it to work for the input port, so I'm just going to try and put it just from the 5 volt. So this should just be a power source that comes out of the board and into this breadboard. So I'm going to put it on the red in the positive channel and the black in the negative channel. And you can see how it's set up here to 5 volt power and ground. Nope, still works. So now I have plugged it in from the port 7 here, and the ground coming from back into the board. It's entering in here, and then this row 5, column 5, is sharing the same charge coming from this red line, and then moving over to the long leg of the LED. And I have the ground leaving from where the short leg of the LED is. And I have this set right now to LED pin 7. And we should be all good to go. I just wanted to share what I learned here, and mostly it's just about kind of how breadboards work. And where I was struggling was I was trying to follow the circuit diagram, but I didn't really understand that the columns here are all kind of what connects the electronics together. So like this column, anything, the input that I would put there. So in my diagram, we needed to have the input come into this line, this socket, and then a resistor, which would take that power and reduce it so it was safe for the LED. I needed to make sure that I was inserting it on this line, which I was doing, and I really think it has to do with just like finagling it so it was correctly inserted in there. And then the output, so this would have the live power through it. It could power the LED through the long leg, like okay, long leg, see the bent one? Like so. And then taking the output of that, because it would share the same column, and bringing that back to your Arduino. So I was able to debug my LED because I wasn't sure if it was something wrong with my sketch. So I was able to just power the whole board. I was able to power just the whole board by using this top channel, because when you power this top channel, see there's a plus and a minus. The plus gets everything along this line. So I was able to remove the sketch from the equation by changing this so that it could use the resistor there, and then take that channel and bring it back, because I wasn't sure if it was the LED that was bad or the sketch was bad. So after that, I was able to resolve, and it seems like maybe these resistors are a little finicky in getting them into the breadboard. So first project success. I hope next time I'll be working on something a little bit more complicated and more learnings.